This video is a short demonstration on how to use the cell membrane models to show the process of passive transport through facilitated diffusion. In this example, we have a cell membrane, which is made up of a phospholipid bilayer. Inside of the cell membrane, we have 8 water molecules, and then 12 water molecules on the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, the first question in this demonstration is whether or not water can pass directly through the phospholipid bilayer. And the answer, as shown by this model, is no. The water cannot move directly through the phospholipids. The only molecules that can move directly through the phospholipids are small, uncharged, nonpolar molecules. Water is polar, so it doesn't fit that description. Some examples of molecules that would be able to move directly through the phospholipid bilayer would be gases such as carbon dioxide or oxygen gas. So in order to move the water across the membrane, the cell has to use a protein channel. This is a protein channel called aquaporin, which is demonstrated with this label here on the back. And we're just going to place it on the cell membrane. Now, water always moves from an area of high concentration to an area of low concentration. So the higher concentration is the outside of the cell because there are 12 water molecules. The lower concentration is on the inside of the cell where there are only 8 water molecules. So the water is going to move from the high concentration outside to the low concentration inside. The water will pass through the aquaporin into the cell until there's an equal balance, an equal number of water on the outside and water on the inside. So in this case, now we have 10 water molecules on the outside and 10 water molecules on the inside. If water is entering the cell, that will cause the cell to gain mass and increase in size. So the way that we'll demonstrate this is by adding a piece to our membrane and showing that the cell is increasing in size because the water moved into the cell. It's gaining mass. Now, let's say that there are more water molecules inside the cell than outside the cell. Let's put 2 more water molecules inside. Now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 water molecules inside the cell and only 8 water molecules outside of the cell. In this case, water would move out of the cell because, again, water is going to move from a high concentration to a low concentration. In this case, the higher concentration is inside the cell, so the water molecules will move through the aquaporin out of the cell until there's an equal balance. Just as when the water moved into the cell, it caused an increase in mass, when water moves out of the cell, it will cause a decrease in mass. So we'll demonstrate that by removing a piece of our membrane and showing that our cell is shrinking in size. The second part of this activity demonstrates the movement of not water, but glucose through the phospholipids. So we're going to remove all of our waters and set them aside. We're going to remove our aquaporin and replace it with another molecule. This is the GLUT carrier protein, and its job is to carry glucose across the cell membrane. The directions for the model say to put 1 glucose on the inside and 4 glucose on the outside of the cell. Again, glucose cannot move directly through the phospholipid bilayer. The reason is that glucose is a large molecule. Large molecules, just like charged or polar molecules, must go through a protein. This is called a carrier protein because it actually swings back and forth to carry the molecules across the membrane. In this instance, the glucose is going to move, just like the water, from a high concentration to a low concentration. The high concentration is on the outside of the cell because there are 4 glucose molecules. The low concentration is inside the cell because there's only 1 glucose molecule there. So in this case, we're going to move the glucose molecules through the carrier protein into the cell. Again, they're moving from a high concentration to a low concentration. The cell is not expending any energy for this to happen because both the glucose and the water molecules are moving from a high concentration to a low concentration all on their own. The cell is just providing a protein channel or carrier protein for the molecules to move through.